We talked a little bit about how the selection process of my materials had to do with how it was to be used, but I'm going to tell you a little bit about selecting lumber when you go to a building supply place or hardware store to maximize your probability of finding pieces that are really good and useful for what you're doing. So usually when you go to a lumber rack, one of the first things that you're going to see is the end of the board, and that's the first thing that I'm going to look at. So what I want to do is I'm going to look at what we call the end grain of that piece of material. And what I'm looking for in that end grain is to make sure that I don't see an excessive amount of what's called checking. So checking are these cracks that are radiating from what was the center of the tree. So you can see these are the annual growth rings, and this was probably our center of the tree somewhere around down here, right? So we can see this arcing bands of summer growth, winter growth, summer growth, winter growth. And we could, based on that, if we had the entire tree, we could tell how old this was, right? But what we're really looking for is a minimal amount of checking, because when you see excessive checking or cracking in the end grain, it's typically indicative of improper drying or improper storage. Remember, wood is like a whole bunch of straws all held together in a bundle with little openings on the ends of them, and that moisture migrates out these fibrous end grains more rapidly than it does through the edge or the face of that piece of material. So these cracks can be really aggressive and can run deep into that piece of material, and for all practical purposes, most of this is going to be something that you're going to want to cut off because it's not going to take a fastener well, and it's probably going to continue to migrate. So the first thing I'm looking at is minimal checking. The next thing I'm going to do is I'm going to look down. Oh, I can't really do this very well with this camera angle, but what I want to do is look down the length of that board. So I'm going to bring my eye up like I'm sighting down a rifle barrel and look down the length of that board and see if I see any warp or dramatic curve in that board, because I want that to be absolutely minimal. The next thing that I'm looking for is what's called cupping, which would be any dramatic curvature across the width of that board. Boards like this are moving in opposition to the annual rings of the tree, so its tendency is to curve in this direction. And knowing that also sometimes informs how we put these pieces in correspondence to each other when we're building things. So last but not least, I'm checking to see if there are knots in the piece of material, right? And a knot is where a tree limb came out of the side of that tree. So that's what we call secondary or tertiary growth coming out of the side of the tree. And everywhere there is a knot, there's tension held in that material. And if you're cutting longitudinally and ripping that stock, that tension will usually be relieved as you cut through it, causing the material to warp more than it was because of the tension around those knots. And often when you look down the length of that board, you'll see it pulling around where a knot is on the surface of that material. So the general rule of thumb is we're looking for a minimal number of knots, and ideally none larger than a quarter, right? And last but not least, we're also making sure that there's a minimal amount of what's called wane or runout. So wane is when they cheated you a little bit and you got a little bit of the bark off the edge of your piece of material that can result in a sloping shoulder. And runout is when it's cut out of a piece of wood that had the grain growing eccentrically. And that means that when I say run out in the grain, I can see this grain runs along and is approximately parallel to the length of that piece of material. But in pieces of material that were not properly milled, you can potentially see a lot of run out. And although it's not a problem with some materials, other materials are highly sensitive to run out, like redwood. You're also not always going to find boards that are perfectly straight. So if there's a little bend or crook in the end of it in the last 6 or 8 inches, you may well just be cutting that off and, kind of coming to terms with the fact that there is typically a minimum of 10 to 15% of waste anytime you're buying wood products like this. It's just, unless it's an engineered material, where those percentages might go down a little bit more. Okay, so I flipped this guy over and I went ahead and pre-drilled for all of the lags that are going to hold this outside face on. And not only did I pre-drill them, one for slightly oversized for the width of the shaft through the first board, and then one slightly undersized for the threads to bite into the second mate there. I also went ahead and ran a lag into each one of these to pre-cut the threads in so that when I have it outside on site, it's going to require less torque because it'll already have a path to follow. Now the next thing I'm going to need to do is take this top off, because now I've got to do my drilling out on the interior of this, because it's going to be what we call a blind mounting, where you won't see the hardware on the outside of this box beam, because all the hardware is going to be mounted on the interior. So I'm going to disassemble the top, measure and mark out the interior, drill that out for the masonry anchors that are going to be used to secure this onto a brick wall. Okay, I went back outside and I double checked to see where is the best place to put my anchors that are going to go through the inside of this box and attach to the brick that will be behind it. So I need to stay as close to this edge as possible, because the wall only comes to about the center of this. So if this is my wall, the deeper I go into that wall, the more strength that fastener will have. But I can't come too far up against this edge, because I have to have enough room to be able to drill for my counterbore and to drive that fastener through without abutting against this. And you can see that in a drill like this, there's really a low profile between the center of the chuck and the top, and that's by design. That's highly desirable. But you can see it still means that I cannot get in as close to this wall as I want to, unless I come back to my friend, the Forstner bit, which is going to give me that extended reach, and I take advantage of this driver system or installation system that comes along with the type of masonry fasteners that I'm using. These are generically referred to as Tapcons, because they were the first people to come out on the market with them, but it's a very effective way to hold materials into masonry without too much damage to the masonry, and with the ease of being able to extract them afterwards should you need to be able to remove them. Things like wedge anchors are very difficult to get out of a wall once they've been installed because they wedge from behind. So in any case, I've got the advantage of being able to use this Tapcon system. It comes with drivers that are appropriate for the particular Tapcon that I have. It also has the appropriate drill bit sheathed inside of that. So this whole assembly can go on the end of my cordless drill driver, and I can come off, drill my hole through into the masonry, slip this back on, and drive that fastener into the hole that I've made in the masonry. So I'm going to go ahead and do my layout down the line. And again, one of the reasons that I'm pocketing these screws is they don't need to sit flush below the surface because there's enough room in here around the radius of that tube that's going to be contained in there. But I do want more of these threads. You can see that right now I've only got about 3/4 of an inch of threads that would be presenting itself into that masonry wall. So I want to counterbore this enough that I'm not exceeding half of the thickness of the cross-section of my material, but the smooth shank will be engaging the material, and all of these threads will be engaging my masonry because I'm going to create that pocket for this to sit down into. And I can look at this and see that when I'm between the 1 and the 2, let's take that back a little farther. When I am when the center hole aligns with my material, then I've hit the right depth. So that gives me a good point of reference. I don't have to mark this up. I can just go about my business. All right, I just wanted to tilt this up on edge so you'd have a little bit better view of what's going on inside of that box. So I put my offset at 3/4 of an inch. And because it was tricky to get in there and mark, I just took a piece of stock that was 3/4 of an inch wide, and I just lay my marker right up beside that and just run all the way down the length and just mark that in place. I've also marked the location of where the fasteners are coming through these pieces here because it's preferable that I am offsetting the position of these anchors so that everything isn't going through at the same point, creating a potential weakness in that cross section. So the location of those masonry anchors will be sensitive to miss stepping around where those bolts are coming, or lag bolts are coming up through the bottom side to secure these in place. Drill bits like this extended length drill bit can often get us out of situations where we might be tight up against a wall like I am here and unable to make that full reach through that material. So know that these are available through a number of different sources. So I don't know what day of the week it is where you are right now, but for me it's Friday and it's getting late in the day. It's raining on and off outside, so I don't think that I'm going to attempt to mount this today because just, I don't have to. So I'm going to wait for better weather during the weekend and see if that doesn't present an opportunity to get this tied back up. But what I am going to do in the meantime, since it's going to be sitting idle, is I'm going to go ahead and take this top, and I'm not going to put all the screws back in that top, and I'm going to probably put about half those screws back in. And that's just taking out insurance against this warping or towing out between now and when I take this outside to mount it in place. So little time spent securing it in place might save me a lot of aggravation down the road. Alternately, I could put it on and put C-clamps on it, but I'd like to let the screws do the holding. So we'll see where we're at with this weather-wise, and if we can't proceed and get this guy installed shortly.